Seriously. All right, so
Okay, ladies and gentlemen, welcome to this afternoon's chat on disk encryption for Linux. Mark Merlin is our presenter, and he's been using Linux for more than 10 years, both as a sysadmin and a coder. And unlike some of us, he doesn't spend all of his life sitting behind a computer. He likes to get out and snowboard and race his cars and fly aeroplanes, I believe, as well.
yeah, that too.
So without further ado, Mark Merlin.
Thanks. Since we're here, we'll do the talk in reverse. So this is the RDMH or initramfs on Debian. It has basically a small RC-like system running a bunch of scripts. Right now, it's actually asking me for the password that it's going to take once from me. It's going to go a little bit quickly, but it hasn't encrypted the root partition. It does the pivot root, which is now using the real file system on HDA1. Now my real root file system is booting. Here it showed it went pretty fast. Partition 2, 3, 7, 8, 9, and dev mapper. Those have been de-encrypted using the same password I just typed, and now it's booting my regular system. You can see how well it's configured with probably error messages that I've had for years. And then from now on, it just looks like a regular Linux machine. It's just a little bit slower, but getting a bit ahead. But it's really just a few percent. It's really not that bad. All right. So hopefully it won't blow up on me now. Hold on. Have faith. So I do apologize about looking at the screen, which is extremely rude, but unfortunately, I don't have much of a choice right now. I hope you can all read the fonts, because that's what the presentation...
Encrypted?
Yeah. People say I don't need encryption because no one can read what the hell I have anyway. Go away, die, and die. I think that should do it. All right. Still kind of blurry, but hopefully with the big font it will work out. Oh, nice. It's actually missing a piece on the side. All right. There we go. We're finally getting somewhere. You know, I should probably, so that my neck still works when I go home tonight, I'm going to be sitting here. So we talked very quickly about what the talk's going to be about. There's multiple ways to do encryption on Linux. We'll be looking at least I'll mention most of them, and the ones that I picked and why, and what you should be looking at in the future, because there's actually a lot of improvements that are being made in that domain. For me, for the most part, will be the Encrypt setup and the Luke's extensions that I'll explain in more details. No, it is not Luke, sorry, I'm your father. Nothing to do with this. It's really just a key extension that you'll want to be looking at. And yes, I do throw stuff at people. Unfortunately, they did not give me any sharp objects. I don't have any pens to throw at you. So I won't be taking any eyes out, but I have some T-shirts. If you ask intelligent questions, do actually feel free to, of course, stop me during the talk. Or if I say something that's incorrect, do correct me too. Thank you. All right, so why do you want to crypt? Because you have way too much CPU and you're doing absolutely nothing with it. So that's a good way to use it. I think dancing windows are lame. So that's something more fun to do with it. And yes, you can read the slides. They're extremely funny. But basically, there's a few problems that come with it. CPU is not your biggest. It's just make sure you don't lose your last password. Otherwise, you're going to be out of luck. And if you have some disk problems, if you lose a bit, because something flipped on a normal hard drive. It's not really a big deal. With encryption, because everything is kind of linked to the previous pages, you can lose a whole block of data, which could be a lot more. So seriously, why do you want to do crypt? Well, I don't know about Australia, but in the US, they have a good habit of putting all your personal information on laptops and then leaving them in random places for people to find. That's a lot of fun, especially in a country where all you need is a name and a social security number to take over someone's life. That's really a problem in itself that should be fixed separately, and I hope it will, but I'm not holding my breath. So hopefully all those people are going to start using encryption soon. Some already are. The government actually in the US has now mandated encryption for all that kind of data. Better late than never. But since most of us don't work for the government, other good uses, of course, are your personal data, especially if you work for a company and you have stuff that's not open source, or financial data, or your own personal image collection, whichever one that may be, music, you name it. So that would be another reason right here. Another one that most people don't think about is if you have your work machine at a desktop in your company, you might have stuff like source code that you don't want to get out. We don't all have open source at work. And most people don't think about the problem of the janitor not really being a janitor, or someone just walking in your company and walking away with a machine that has all the source code on it. In some cases, that would be a problem. So you may want to encrypt the data partition in this case. The last one is if you have a server with really important data like credit card numbers in a colo, again, it's actually not that hard to get in someone's cage sometimes in a colo facility. I don't know if you've been there. So if someone steals your machine, you don't want them to get your data. Same thing. So how to crypt? Some of the ways you obviously know. Applications like Firefox, for instance, are really nice. They have a key manager. You just use an unlock key that you type once, and then it keeps all your passwords secure on disk. You can use programs like PGP, GPG. That's fine, but if your program doesn't support it, if I have to type GPG decrypt before I open my presentation and put in a RAM disk every time, it's not very convenient. So we want something that the application doesn't have to know about so that all get it for free. Encrypting file systems, we don't have that many on Linux. But however, we have overlay file systems, and those are two examples. EncFS, which was the one most people knew about, and eCryptFS, which just got added to the Linux kernel and is being developed as something that should be quite interesting in the future. And block level, well, even today for some actually. And block level encryption, which is the one that most people are using today. And we'll see there's multiple ways to do it. So we just talked about that. Overlay file systems are actually, in my opinion, mostly the future for most encryption cases, because encrypting the block device is not very convenient if you want to resize the file system later. Or let's say you have a bit that flips in your inode table. Well, you may lose the entire block with the inode table, and that's just bad news. So on one side, it's nice to encrypt the block device because the file system doesn't have to be aware of it. On the other end, also, you could have any kind of file system. It will just hide your data, how many files you have, how big they are, and so forth. It also works for swap, for instance. So those are good reasons to use block device. But if you only care about encrypting a portion of your data, maybe your home dir, or just one portion of a file system, then an overlay is really the way to go. And in essence, what it does is it saves files on your hard drive, but the file names themselves are encrypted, and the data inside the file names are encrypted too. So even if you got to them, you would know you have 10 files, but you have no idea what they're made of, or whether they're GIF files or something else. So block level, we have different ways to do this. The two big ones are loop AES. Some people argue it's actually slightly faster. It's also, I'm not going to go into very deeply into the crypto details, but it's supposed to be very slightly more resistant to attacks than decrypt. But effectively, for most users, it's really about the same. One of the issues that I have with it right now is it's not as widespread as decrypt, so most of the userland tools don't have integration for it. If all you do is you just use it from the command line once in a while and decrypt your stuff yourself on your own laptop, that will be fine. If you would want to have in a script that do this automatically, like my laptop booting, I just typed my password once and everything came up. It's nice if you have integration in your distro for it. If you have users who don't even know about encryption and you just want it to work for them, that also makes a difference. And when I looked at Loop AES, it didn't do a very good job to make that easy. But hopefully people will develop things to help there. So for now, I've been using Encrypt, which also is part of the device mapper layer. So that means it's just easier to deal with because there are existing tools for it. And then Lux, which I just talked about earlier, which puts a good key management on top of it. So crypto, it's a bunch of acronyms and letters. It's a lot of fun. I give you some URLs that you can read later. But basically, if you see those, CBC is really the one that you'd want. It uses the initialization vector. The previous block does an XOR. And that way, the data is more random looking when you just look at it and try to do crypto analysis. Witchcraft crypto algorithms. There's a dime a dozen, but most people have been using Blowfish in the past because it was fast and pretty good. Now this AES, which is just standard that most people are using, and because it's been written in assembly language for Intel CPUs, it's actually about as fast as Blowfish. Now, if you really don't like that, you have the good old ROT26, and if it's not good enough for you, you do a triple ROT26. That way it will be much more secure. You can pick what vector you want. You can pick lots of things. But at the end of the day, really, the defaults in Encrypt setup are what most people agree on, and I would just leave them alone because I don't think the other ones are any better, quite frankly. But if you don't like them, you can change them. So Lux was actually a bunch of patches against Encrypt setup that have been added over time. On Debian, Ubuntu, and some other distros, it's actually part of Encrypt setup now, so you don't have to worry about it. If you look at the man page, it's actually two sets of commands, the old commands and the new ones that all have Lux in their name. Forget about the old ones. Lux is really where you want to go. The way it used to work is it had that one key and would encrypt your whole file system with that one key. If you needed to change it later, the procedure was decrypt everything and re-encrypt with a new key, however long that took. And if you wanted to do it on the fly and you felt really lucky, you could DD it into a pipe, re-encrypt it, and put it back on your file system and hope you didn't have a power failure in the middle. Yeah, we have better now. It's called Lux. Forget about the old ways. Basically, Lux has that same one key to encrypt the whole file system, but you never see that key. It's just a random number of bits. And that key is encrypted with up to 8 passwords. And that's what you are using to unlock that key. Effectively, it works just like PGP. And that's really the way to go. I find that 8, unfortunately, is not necessarily enough in some cases, but for most people, it will do. Also, another nice 5-letter acronym this time. What it does when you type your password, it will actually encrypt it. Sorry, it will crypt it many, many times. It uses a hash function like 10 or 50,000 times. And that way, if you try to do a dictionary attack, you just have for every single password encrypted that many times. And that's very expensive to do. That way, you're more secure. So before you even go anywhere, if you read some how-tos on the net, they tell you should wipe your entire file system. It has nothing to do with Kleenex or window cleaning fluid. It's really just about putting random data on your hard drive. It sounds like a good idea on paper, but if people tell you how proud they are that it took them 3 days to get the random data to get all that randomness over their hard drive before they did a crypt setup. I don't know how patient you are or how many hard drives you have to crypt or how big your hard drives are, but I'm not that patient. The wipe command I did it over there is actually slightly better. It uses some random data and then it uses that so that it doesn't have to read from random every time. It's faster, but still writing 500 gigs, even at CPU speed, it's still slow. And sorry? I just got a new drive. I want to crypt it. And it takes me 4 hours before I can even put any data on it, according to those documentations. So what they're trying to do is they're trying to put noise on your hard drive so people don't know what you have. But let's be honest, most of us are using ext3. It has superblocks, it has inode tables. They're about in the same place every time. So That's called known plain text. People know what that data is going to be, except if you wrote your own file system or using something very obscure. At the end of the day, yes, sorry.
I'll just say that for a new drive, that's not really necessary. Just use DD from dev random.
That's what actually wipe is something is supposed to do this, except better,
It
because
doesn't need
DD.
to be secure at all, as long as it's even partially random.
Well, actually, wipe will use dev random data, but it can optimize it in a way that you don't have to read from random, which is kind of slow. So it gets a seed from random.
It doesn't need to be secure.
That my whole point is you don't even need any of that. So people will see how they can optimize randomness, and I say don't bother. At the end of the day, what happens is the blocks that you have data on are the ones you wrote, and you already have known plain text. You should just have a good crypto algorithm that makes known plain text not a problem. And decrypt, crypt setup don't really have a problem with this. Otherwise, it would be totally a waste of time. Another question? Yes.
Yeah, I'm sorry. I'm confused about what threat this is defending against. I just don't understand.
So am I. That's why I'm saying it's useless. Basically, people are saying on the internet, oh, but you want that really random data so that you're all safe.
If it was about my old data in plain text and you want to make sure it's gone, I understand that.
Yeah, no,
That's
no.
why I said buy a new drive.
Right, no, this is actually, they tell you to do this on a brand new hard drive filled with zeros. Because their point is that, well, zeros are known data. So if you write data around it, they'll know where your actual data is because it's not zero. And I say this is really people with too much time on their hands who may not actually understand crypto very well.
It hides how much data you have on disk, which
Yeah.
may let an attacker know how valuable it is and how much effort to spend in cracking it.
That's pretty much it, yeah. Is it really worth it? I mean, okay, sure, right. But, okay, I have 300 megs on my 500 meg hard drive.
So that's not your point collection then?
Not really. It's somewhere else, exactly. Or maybe I didn't get enough, I don't know. So yeah, that's the whole point. Really what it's protecting against is not really a whole lot. It's not worth your time, in my opinion. So forget that. I'm just mentioning that because there's one how-to that said it, and then everyone copied from that guy. So when you read it 10 times, you think it's really important, and I don't think so. So you can read the man page, but very quickly how it works is you do a Lux format, which puts the Lux data blocks on that raw device. Then you open it, and that creates an entry in a device mapper. I have to give that entry a name. What Paramount uses, we'll talk about later. It just has a convention of using underscores instead of these slashes. I could call that foo or whatever I want. It's really not important. On my laptop, they were called parts 275. So really, it's up to you. If you run DM setup, now you can see that device. If you run a status, it shows you the status of crypt. It could actually be LVM or mirror, because DM is just, device mapper is more than just crypting. And then if you run crypt setup against it, it shows you what cipher it's using, how big the cipher is, how many blocks. Once you don't have to do all this, of course, but once you have all this, you format it and you can just mount it. Note that you have to use dev mapper and the device name that you created. Lux dump is just a way to see what you have inside that block device. It shows you how many keys you have and which ones are used. I did a typo at the top on purpose. It just shows you won't do the dump against the raw device, not the decrypted device. Question?
Just going back to the previous one.
Yes.
Just a little confused the interaction of, because device mappers used for different things.
Yeah.
If I wanted to encrypt most of my laptop hard disk and I want LVM underneath the encrypted partition so that I can then just easily move around partitions and things.
Yeah.
Is that layering possible?
Yeah. You could actually do a decrypt over a decrypt if you really wanted. You're creating a device. What you do with that device is you could crypt it again. You can, same thing with LVM. You can do an LVM over an LVM.
Oh, okay.
So there's no restriction there.
Except for your sanity.
Yeah. And the other thing is if you create a block device, it makes it difficult to change that size later. So you could make it work, but changing the size after the fact is going to be difficult.
Which is why I want to encrypt the block first and then the other middle underneath.
Right, you could do that. Yes, absolutely. So that just shows you a dump. When you start it, it just uses key slot 0. The other ones are empty. You added a key with Lux add key. One little patch I added is saying which key slot you want a new key in, which is kind of important when you have a program. You want to know where which key slots are you using. And by default, we didn't do that. So I don't know if your Encrypt setup has it yet, but it should soon, hopefully, because it did get accepted in mainline. So how do you add a key? It asks you to first, you have to access the actual secret, which is used to decrypt everything. So before you can do that, you have to type, it says any loops passphrase. Right now, it's only key slot 0. For some reason, it asks you to type it twice. Don't ask yourself why. There's no good reason. And then it wants the new password twice. That makes sense. And now I just created a key slot number 4. The other two ways are just to show you how you can do it. I'm adding a key slot number 5 from the command line, just echoing the old password. And I said the old, now it could be any of slot 0 or slot 4, and a new one, which is test 3. And the last one is actually reading from a file. A file could be a pipe, it could be a FIFO, whatever you'd like. This is just so that you don't have to do stuff from the command line, and your password doesn't show up in PS, basically. Deleting a key is very easy, too easy almost. Don't delete your last key, because if you do, you're really going to be out of luck. You get a small warning, but as you see, you don't need a password. Anyone with root can delete keys. Because it's only a key slot entry, you don't need to have any credentials except writing to the block device to remove it. And now this is what the dump looks when I remove key 0. I have 4, 5, 6, which I just created. Even if you delete your last key, as long as it's mounted and working, you're still good. So your data is still there until you unmount and you do a loops close. When you close it, now your device is gone. And next time you mount it, you have to have a password again. So that's what I'm doing here. If I'm echoing test to mount it, now it doesn't work anymore because I deleted key slot 0. However, I can use test 2, which was slot 4, and that works again. Moral of the story is, know your key slot 0 very well, or you have more than one. Key management. So I just talked about key slot a little bit. The idea really is to be able to have more than one key when you have users who have their own password. Because as everyone knows, users always know their passwords. They remember them because they print them on their keyboard or their monitor. And one day you say, oh, what did you do? You erase it, and the next morning you don't know what their password is. So since all their data is gone, you don't want that. So essentially you create passwords, a backup password for them that you put in a different key slot so you can come back and rescue their data. That's after they have given you the proper offerings of cash, women, cars, whatever you fancy, of course. So you can't recover, so that's why you make a backup key, and that's what I'm showing here. One way I've done it is you just create a hash. It could be any kind of, a salt. That could be anything you want. You then add the login name, and you just hash that with, here I'm using SHA-1. So what this creates is it just creates a string that's always going to be the same for any given login. You have a simple program like this in C or whatever, which is not readable because you don't want that salt to be known. And then if a user foo comes in, you say gen user key foo, and it spits out that magic string that you can put into their machine to get back to their data. And that's what I'm showing there. I'm doing gen user key. Then I'm pasting that string as a passphrase. It shows that key slot 2 got unlocked, not the other ones that I don't know the password for. And then I can re-enter a password for key slot 0, or ideally the user would be typing that, and then they're back in business, and you delete key 1, which is the one that was lost. That's just a longer slide showing what Luke's dump looks like. It's really a bunch of numbers which are not all that interesting to most people. So the only ones you really care about is just the key slots, and if you want to verify which kind of cipher you're using. So how can you crypt your system, and which are the different ways to crypt? One of them would be, we talked about laptops like this one. Well, I've actually, after a long trip, left my laptop in my bag by the baggage belt. And it took me about half an hour to realize I had done that, by which time it was gone. This is when you realized, what kind of data do I have on my laptop? Is my root file system important, or how about my data partition where I have all my image files, or movies, or whichever those may be? Or company data if you're a more serious person, or both. So in that case, you do want to encrypt as much of the system as you can. That way you don't have to worry about what's okay and what's not okay. If you get my laptop, you'll get free hardware, but you won't get any of the data out of it. In that case, you want to encrypt the entire system. Encrypting the root partition is a little bit annoying. We'll talk about this later. But the rest, user, var, home, whatever, are pretty simple. On systems like Debian, there's a crypt setup, crypt disk in its crypt. And all it does, it goes to that crypt tab file. On the left is the name of the device mapper device that's going to be created. What is the raw device that contains encrypted data? Where to read the password from. If you only have one partition, it's easy. If you have 5 of them, it's kind of annoying to type your password 5 times. So you can just save it in a little file anywhere on disk. Then you run the init script, it mounts everything, and then you delete it. Of course, automatically, right? Not by hand. And then you can see at the bottom, you have the dev mapper devices, and that's how you mount from fstab. Oh, and where to put that key? People talk about USB keys. I don't really like having a little thing plugging on the side of my laptop when I'm in a plane or something, or I might lose that key. But you can use it as a way to get in, and you can, if it's not there, you do a backup to the keyboard, and you just save it somewhere. You don't have to type it 5 times. However you do it, that's really up to your usage pattern and how many partitions you have. So the root file system is a little bit more difficult. And the problem is, well, you need crypt setup, which is on the root file system. You need some modules which are likely on the file system that's already encrypted. So that's what you saw on my laptop when it booted. It actually mounted an init-ramfs image, which is just a big block device that gets mounted as a RAM drive that has a very minimal system, which has just enough to load the modules, run the crypt setup commands, and asking me what the password is. It does this, it encrypts the root partition, then it does a pivot root, and that makes the new root partition the one that is booted from. On Debian, it's actually very nice because that update init-ramfs, it will pretty much do everything for you. And that way you don't have to make an entire file system and boot your system 50 times before you get everything right. This is what it looks like when you're done. So your root file system is already decrypted. The key is saved somewhere on disk again, so you don't have to type it several times, and then your laptop boots. As you notice, the boot partition itself, that's the only one that's not encrypted because it has your kernel and it has your init image. And you cannot encrypt that because Lilo has no idea how to decrypt it otherwise. So really that's just a small, I guess you can go down to about 5 megs or 10 megs, whichever one. That was the only one that's not encrypted. Everything else can be. And if someone steals your Linux kernel, they just got free open source code from you. Laptops, very interesting slide. You have about 10 seconds to copy it down. Basically what happens is, let's say you mug me, you walk away with my laptop. Well, you don't have my key, but you have all my file systems right now. You can mount something else and copy everything off. So what usually happens is if I have my laptop in the bag, I will shut the lid, it will go to sleep, RAM suspend, and if I lose my laptop, if someone steals it from me, when it comes back from sleep, it locks automatically. This is what this is doing. It looks if it slept more than 20 minutes, and if it did, then it runs screensaver lock. So by the time you see my machine is locked, you don't have the passwords, you reboot. By the time you reboot, you don't have the keys, and then, well, you got free hardware, but you don't have my data. And of course, you all have backups, so it's really just a hardware problem, right? All right, data partition crypt. In most cases, the operating system, really, you don't care about it that much. Encrypting your root partition can be tricky. When I upgraded to 2619, they just made one of the crypto modules a separate module, which did not get put in the init-ramfs. When I rebooted, nothing worked, and I was like, oh, crap. And you boot from single mode, but you don't have any tools on it. The rescue disks don't know about crypt setup loops, and you're kind of saying, oh, I wish I hadn't done that. So unless you're really particular about encrypting every single last byte or everything on your machine, I would say just encrypt your home or your data partition where your source code is or whatever data you have. That's the simplest way to do it. Also lets you use other systems like EncFS or eCryptFS That gives you a lot more options. In my case, it was also because when you have a bunch of users, they really only have their source code that's important, and they don't want to know how encryption works or yet another password that they're going to have to remember, which they're not, so they're going to write it somewhere. And then when they change one password, they have to change the other one, and it just gets out of hand. So this is where PAM mount comes in. PAM mount is a very nice module that shows up in the PAM stack, and at the time you're logging in, it uses the password that you used to log in and feeds it to crypt setup, and it mounts that partition for you automatically. So at the end of the day, if you did your job right, the user has no idea what happened. They just have their data, and everyone's happy. And I listed which places you want to have it in: login, XDM, JDM, so forth. I think that's a slide afterwards. Yeah. So pammount.conf is the config file you care about. Yes, question?
Sorry, will PAM mount also go the other way? And if they change their password in the OS, will it offer some way of adding that to the key
Right.
store?
I did not actually find, I don't think it does that. I looked for that. I actually instead wrote a script that takes care of key management because it looks like it hasn't been taken care of yet. The problem is you cannot change the password. In Lux, you have to make a new key slot with a new password and then delete the old one. And for that, you have to know which one is which. What is the user password? What is the system recovery password? Who knows? So unfortunately, I don't think anyone has integrated that into PAM itself. And that's why I use a third-party script that I have on my webpage along with this presentation, which helps you with that.
Oh, cool. Great, thanks.
But I would also say changing the passwords, the more you make users change the passwords, the less they know them and the more they write them down, right? So it's really for when it's been compromised, or if you have a company policy maybe once a year, anything more than that, you're creating with yourself more problems than you're solving with encryption anyway. You probably know that, but you'd be surprised how many people still are forced to do this. All right. So this is what PAM mount looks like. So the trick is some documentation tells you to run that PAM mount setup in the entire PAM stack, whether using cron or SU or anything that goes to PAM. That's actually a bad idea because some things that go through PAM, like SU, may not have a valid password to give out to the PAM stack. If you SU to yourself, that works. But if it's a cron job as root SUing to nobody, there is no password given there. And due to a bug that was until very recently in PAM mount, it would actually cause a problem in the library, which then would cause cronly to segfault and cause a lot more problems than you're trying to solve. So at the end of the day, you really don't need PAM mount in anywhere else than something that you use to log in. And that's that very nice little piece of shell at the bottom. I think login SSH and whatever XDM that you use will probably be enough in that case. And then I have a separate PAM mount file for common auth. It's just different file names on Red Hat, but same concept. So encryption speed, we've talked about this. Those are all the caveats. This corruption, well, have backups, because if you have a bit flip, that could cause you problems more than they would before. Encrypting your root may not be worth it in most cases. Lux, I really wish it had more than 8 key slots. If I have more than one user using a machine, that's fine. If I have more than 8, I'm out of luck, and I have to look at a different setup. Now I'll start a stopwatch. You have about 10 seconds to copy all those URLs, but of course you'll find them online. This is more reading. Other things that can be done, we talked about more than 8 keys. I think for most of your users, layered encryption is really the way to go. It's just easier to handle, and you don't have to worry about as many problems than you have with the whole block. The biggest thing I think for me is you can resize partitions. That's really a nice feature, and you don't have to do the whole partition. I use VMware. If I have that VMware image on encrypted partition, I haven't benchmarked it, but it really feels slower. So sometimes it's nice to just be able to do half. And that's where eCryptFS comes in. It was just recently added to the kernel, and that probably is something you want to look at if you think that will be good enough for you. And then we have time for questions.
Is there any way to integrate this with a smart card so that you can, say, let the smart card decrypt the key for decrypting the file system, so the user only has to remember a PIN, say?
So you're replacing a PIN with a password.
Correct, except that you don't, with a USB key, if you turn your back for 10 minutes, someone can duplicate the key
Right.
and then reuse it later.
Right.
If you use a smart card to decrypt a key that's even stored on the laptop, then if you've got the smart card, you know no one else can get into the machine.
Right.
They can't duplicate it because they obviously won't tell anyone the certificates. Is that possible through PAM?
So the question is how to use a smart card instead of just typing a password. It is doable, but at the end of the day, you need to feed a passphrase to crypt setup. If your smart card looks like a USB hard drive, it's pretty simple to do, but most don't.
Certainly.
So you need to write some code to talk to it at a time where USB may not be up yet if you're encrypting your retry system. So it can be a little bit tricky, but however you do it, you need to get some passphrase back from that smart card. And then you can have it in RAM, just crypt it, send it once to the crypt setup, and then you're done. It never touches disk. Yeah. So you could, but you have to write a little glue, which will work with your smart card.
So that hasn't been done yet?
Not that I know of, but it really is smart card dependent. They all work differently.
Yeah.
Probably someone has done it somewhere.
Would you say this would be a good way of encrypting USB keys as well, or is it better to go, say, with one of the layered systems? Because I often find that if I will have a USB encrypted key, I might be on a OS 10 or PC where you want to actually get at the data that you've got with you. You don't have your own laptop with you. You've just got
right. Some of them actually, I think EncFS works also on Windows. Lux, in theory, is supposed to be an open format, but I haven't seen the Windows version yet, and I don't know about Mac OS either. But I would say that yes, I would go with the user level one or one that is layered, because I know some of them are multi-OS. Crypt setup and DMCrypt aren't.
Are some forms of encryption capable of of rebuilding at least part of the image if there is a corruption?
Well, what happens is that if you lose a bit, the way encryption is done is one page depends on the previous page. That makes it more secure so that you don't have a repeating pattern. And however, if the previous page got damaged, now you're losing a whole block of pages all at once. At some point it resets and starts over, but if you lose just anything, it's like a gzip file. If you lose a bit in the middle of gzip, because the other blocks are dependent on the previous one, you lose a whole piece of data. Recovery, you can have a lot of luck there. I mean, if you happen to know which bit you lost and what value it had, obviously that's easy to fix. But there's no redundant data or ways to recover from that. You should really have backups, and it goes back down to that. Actually, the nice thing with eCryptFS is that the encryption pieces are stored inside the file, so you can save the files separately on any device and copy them onto a different machine that also has eCryptFS and read them, because everything is contained into that one file, and that you can copy with tar or anything that is not encryption aware, and everything you need is, think of it basically a password gzip file, but it's for every single file that you have. Did that answer your question, more or less?
Not really.
Not really, okay.
The question was whether some forms of encryption are better at being able to recognize.
Oh, recover, I'm sorry. Yes, but it also makes the encryption weaker. So by doing this, you're actually giving away security and making it much easier to crack your data. So the answer is yes, but you probably don't want to use them.
I have a question related with if you have compared the solution you are doing with other privative solutions like PGP disk or I don't know. What about the performance?
Yeah.
The benchmark between these and other options. And another question is about if it's similar to the smart cards, if it can be supported, for example, with trusted platform modules, the microcontrollers that are in the new laptops, for example, in Lenovo's ThinkPad, they came like a smart card. If it has support for this, can work well with this.
So, okay, the question was, oh yeah, actually you have the question since that's on the microphone. Actually, eCryptFS has support for TPM in laptops, in IBM laptops, or Lenovo now. So it's really just about a driver issue, and there are some people who are doing that. And eCryptFS will do that for what you were asking. Now, it won't necessarily work with any crypto card you throw at it, but that's where you need to have some glue. And it's really up to the person who gives you that to provide it or for you to write it. But you can definitely do that, yes. Yes?
Can you change the encryption chaining length? So if you did have a bit flip, it would, the damage wouldn't be as severe?
That was the question that was just asked there.
Oh, sorry.
Yeah, you can. And if you change to something where it's not as severe, you're also giving up some security. The reason why you XOR the page with the previous one is just it makes your data more random. There's actually on the Wikipedia page, that one of the links, they show ECB versus, I think it's ECB versus CBC, and they show you a Linux penguin encrypted with ECB, and it doesn't look the same, but you can still tell it's a penguin. So your data looks pretty similar if, on a graphical format, which is a way to show you that it's really not as good. And then they show you the other one, and it just looks like random noise. And that's what you want.
Okay, we'll have to cut it short there, unfortunately. It's time for the end, and there's about 5 minutes left till the next talk starts. So thank you very much, Mark.
You're welcome.